So I'm super excited to present this lesson to you today on 10.2 because it's just something that is really fun, really interesting. Rational exponents. That means your exponent that you're going to deal with is a fraction, just like this 1 over n right here. A to the 1 over n power. If your numerator of that exponent is 1, the denominator is n, is going to be the nth root. So if it was the 1/2 power, it would be the squared root. If it was the 1/3 power, it would be the third root or the cubed root. Looking at this first example, we have the 1/2 power. So the 1/2 power is the same as the squared root. So this is equal to the squared root of 25. Notice when it's the squared root, I don't have to put an index of 2 right here. We leave that off, and when you don't see an index there, you just know it's the squared root. So I'm going to erase that. Anyway, the squared root of 25 is equal to 5. On example 2, we have 16 to the negative 1/4 power. The very first thing that I want to do is change that 1/4 power, that negative power, to a positive. And we're going to make that exponent, we're going to change the sign of that exponent to make it positive by moving it into the denominator. So now it's 1 over 16 to the 1/4 power, which is the same thing as 1 over the 4th root of 16. And the 4th root of 16, remember how I showed you to do the 4th root, the 3rd root, and so forth in your calculator. The 4th root of 16 is 2. So our answer to 16 to the negative 1/4 is 1/2. And now we have negative 27 raised to the positive 1/3 power. So that's the same thing as saying the third root of negative 27, which is equal to negative 3. See, I told you these would be fun. Kind of a breath of fresh air. Now, my colleagues, when they watch this video, may get on to me a little bit, but this right here I call a PR problem. And you can just remember we go to PRCC, so it's a PR problem. That's when your rational exponent has a numerator other than just 1. So down here you see our, instead of 1/2, it's 3/2. Well, that means your, let's just write one up here. Your numerator is the power, and your denominator is the root. And this definition right here just sort of confirms that. A is going to end up being the nth root of a to the n power, and you can see that right here. And so you can write that as n roots of a to the mth, or you can write that as the nth root of a to the m. They're one and the same. It doesn't matter the order. So basically, I can write on example number 4, I can write this as the squared root of 9 cubed, or I could write it as the squared root of 9 cubed. And if you notice, if you hear what I said the exact same thing both times, but it's written 2 different ways, but again, they are equal. On this first, I put the squared root inside of the cube, and on this one, I put the cube inside of the squared root. But either way, it gives you the same answer. So let's just go with, and you can type it in your calculator as 9, put your 9 in parentheses, caret key, parenthesis 3 divided by 2. You can type it in your calculator that way if you would like. But I'm just going to do it by hand. So 9 cubed is 729, and then when you take the square root of 729, we get 27 as our answer. So it doesn't matter which way. I've given you a few options to think about this. We can type it straight into our calculator like this. We can say the square root of 9 is 3 and 3 cubed is 27. Or we can do what I just did and raise 9 to the third power and then take the square root of 729. So on number 5, we have 0.09 that we're dealing with, and this will be the squared root to the third power. And honestly, I think I'm going to just type in my calculator. Again, the way I would type it in the calculator, let me do this in a different color so it doesn't confuse you. I would say 0.09 in parentheses and raise it with that caret key and say 3 divided by 2 and close those parentheses. And we get 0.027. And again, you can do it, you can take like the square root of 0.09 and do it more by hand, I guess. And the square root of 0.09 is 0.3. And you would have to cube 0.3, and 0.3 cubed is 0.027. So it's the same thing. So on number 6, I want you to notice this negative. Basically, this -1 right here is on the outside. So I'm going to just kind of let it hang out. And I'm going to work 27 to the 2/3. And whatever my answer is, I'm just going to multiply it by -1 at the end. So 27 to the 2/3, that is a third root. So remember, it's a PR problem. Power over root. So 2 is the power, 3 is the root. Anyway, so it's the third root of 27 squared. And if we're going to do it by hand, it may be better to think about that as the third root of 27 and square it at the end. Either way, it doesn't matter. And this is something you can still put in your calculator, because off the top of my head, I do know what the third root of 27 is. It's 3. And then I can square 3 to get 9 for an answer of -9. So on number 7, we do see a negative again, but it's in a different spot. It's not even with the base at all. It's in the exponent. So what I'm going to do, I'm going to change that to 1 over 32 to the 2/5, to the positive 2/5, and it became positive because I moved it into that denominator. So now this is the 5th root of 32 squared, or we could say 1 over the 5th root of 32 and then square it. And I think it's easier like this, because if we're doing it in our head, okay? Doing it in the calculator, it doesn't really matter. Anyway, you end up getting, okay, so the 5th root of 32 is 2, and then 2 squared is 4. You could do this in the calculator. In fact, let me show you. We can do this in the calculator, but not really having to move anything to the denominator. Just remember it was 32 to the negative 2/5. So I can say I would like to put the 32 in parentheses, and then use my caret key right here. To raise it to the power up, now put this in parentheses, negative 2 divided by 5 power. You're going to get a decimal and just press second, PRBFD, enter, and you get 1/4. So on 8 through 10, it wants us to convert the rational notation. It wants it to be in radical notation, basically. So remember, these are PR problems, as in power root. So this is the 5th root of 2x squared, or it's the 5th root of 2x squared, right? It doesn't, we take both of those. Now, if you are going to choose this route that I just did, okay, so this one was simplified all the way. This, the route on the bottom though, I can square the 2 and I can square the x. So that would be the 5th root of 4x squared. So either of these in the box will work. Okay, with this one, notice the negative, this one doesn't have any parentheses, okay? So when it doesn't have any parentheses, I just assume that power is going to the thing that is right beside, okay? If it were going to be 2x to the 2/5, it would look like this, okay? Or if it were going to be negative 2x to the 2/5, it would look like that. But since it doesn't have parentheses, again, I'm only gonna raise the x to the 2/5. So the negative 2 stays out front, and this is the 5th root of x squared, or negative 2 times the 5th root of x squared. I personally like this one a little better, but they both work. And on number 10, see this time it is in parentheses. So we're going to have, everything is getting raised to the 3/2 power. Remember, these are PR problems. So power is 3, root is 2, okay? So the second root of 9 y to the 6th cubed. Or we could write it as the square root and put the cubed on the outside and say 9y to the 6th. Now, this way of thinking about it right here is a little bit easier for me in this case because I can see a good bit of simplification happening. The square root of 9 times the square root of y to the 6th. You don't have to separate it out like that. Cubed, the square root of 9 is 3. And the square root of y to the 6th, you're saying how many times does 2 go into 6? Well, it goes into there 3 times evenly. So now bring that cube down, and 3 cubed is 27, and y cubed, you say 3 times 3 to get y to the 9th. On 11 through 13, it's wanting us to convert the radicals to a rational. So on number 11, the root 2 is not inside of the third root at all. That third root, remember the third root is the same as the 1/3 power, and 7x is inside the third root. So 2 just goes out front. On number 12, the fourth root only has a 6 inside of it. The x cubed is outside of the fourth root. So remember, the fourth root is the 1/4 power. You're going to put 6 inside of that and x cubed out beside it. and you're done. There's nothing else you can do to that. On this one, the square root of a squared plus b squared, the square root's the same as the 1/2 power, and you write your a squared plus b squared in there, and you can't do anything else to simplify it. So now let's look at some properties of these rational exponents, which we've already, I've probably already covered some of these without even, giving you the actual property itself. These really make some great sense. If you have a base times a base, if the bases are the same, I'm looking at one right here, you just add those exponents together. And this ties back into like if you have x squared times x cubed, well, then it's x to the 2 plus 3 power, which is x to the 5th. It really ties back into that. So what this is saying, if you have like a 2 squared times a 2 cubed, then it's equal to 2 to the power of 2 plus 3, which is equal to 2 to the 5th. So it's the same thing. We've actually seen it before, just our bases don't have to be just variables this time. They can be, numbers and stuff. So keep base add. On division, you keep base subtract. And I actually just used this property. Let's see. Right here. When I said when you have a power to a power, you multiply. And so we had y cubed, so that gave us y to the 9th. So we're saying here, when you have a power to a power, multiply. When you have a to the m to the n, just call it a to the m times m power. When you have a base times a base, and they're both raised to that 1 power, you can just separate it out and say that's a to that nth power and b to the m power as well. That only works when they're multiplied. Can you separate it out like that? I was almost wanting to apply that property to this problem, but that property didn't work for this problem because it didn't say the square root of a squared times b squared. If it did, I could separate them out, but they were added together, so I couldn't use that property right there. And the same thing here, when your a and b, a divided by b is being raised to that power, just give them both the power and separate it out if you need to. We've already used this negative rule to where if your power is negative, you can move it to the bottom. And then anything to the 0 power, anything, doesn't matter what it is. If it's x to the 0, if it's 1 million to the 0 power, anything to the 0 power is equal to 1. So let's use some of these properties. So here we have a base times a base. The bases are the same, the exponents are different, but I just add the exponents. So this is equal to x to the power of 3/5 plus 7/5, which is equal to x to the power of keep your base and add your, keep your denominator rather and add your numerators. 3 plus 7 is 10, which is equal to x squared. Who would have thought that ugly problem that we began with ended up being x squared? This is where we have a power to a power. We have the 2/3 power to the 6th power, so power to a power multiply. So this equals 4 to the power of, I'm just going to say 2/3 times 6. And since that 2/3 is a fraction, I'll just think of the 6 as a fraction, and we can multiply across. So 2 times 6 is 12. And 12 divided by 3 is 4. And 4 to the 4th power is 256. Believe it or not, we could have just typed in the calculator. And I mean, literally, just like this, we could have typed it in the calculator. Because there's numbers. Now, if that said x to the 2/3 to the 6th, I wouldn't have been able to just type it into the calculator. But since these are all numbers, I have numbers in the calculator, and I can type it in. Let me show you. So I'm going to think about it. Just as the problem was written 4 to the 2/3, then to the 6th, I'm going to use a lot of parentheses. So I'm going to say 4 to the power of 2/3. Close your parentheses. Oops. And then notice I have opened a parenthesis here and here. So I need to close it twice. And then raise that to the power of 6. 256. On number 16, you might be sad, but I can't type the whole thing in the calculator this time. I got variables, okay? So we have the same base, different exponents. They're being divided. So we use, let's see, this property right here. Same base, being divided, keep the base, subtract the exponents, m minus n. So this comes out to be c to the power of 4 over 5 minus 1 over 2. Now, if you do not want to do that in your head, 4 over 5 minus 1 over 2, that part you can do in the calculator. Anyway, let's just make them both have a denominator of 10. If 5 had a denominator of 10, it was a denominator of 10 instead of 5. How do you make it 10? Well, you multiply it by 2, so do that to the top as well. So 8 over 10 is equal to 4 over 5. How do you make 1/2? How do you make 2 be 10? You multiply it by 5, do the same thing to the top. So 5 over 10. So that comes out to be c to the power of 3 over 10. Let's practice some more properties. We just got one more. So I'm using a few different ones. I'm basically giving this 3/2 power, since this is multiplied, giving it to both of these by multiplication. So this is a squared to the 3/2 and b to the -4th to the 3/2. So now I can say, well, that's just 2 times 3 over 2, and b, I can say that's -4 times 3 over 2. To get a to the power of 6 over 2 and b to the power of -12 over 2. Simplifying that down, a is to the power of 3, b is to the power of -6, but since it's negative, I'm going to put it in the bottom and make it positive.